Hey everybody, this is Mr. Lowry here. We got solving quadratic equations by factoring. So we've been doing a lot with factoring lately, and sometimes it's hard to understand why we want to factor, because factoring is like unsimplifying. But as we learned today, factoring is actually one of the methods that we use, procedures that we use to be able to solve quadratic equations like this. So our main method is going to be factoring. Now what I have here next to me lined up is just kind of a step-by-step summary of what we talked about in class, how to solve quadratic equations. One of the things that we're going to need here, and I kind of wrote this in here off to the side, is the zero product property. So I'm going to go over that really quick. It's super basic, but it's important to know. So if we multiply two things, and we're going to just use variables here to make it generic. If a times b equals 0, then we know something about a and b. We know either a equals 0, or maybe b equals 0, or actually maybe both. But the idea is when we have a product of 0, right? So these two factors multiply, and we have a product of 0. One of those two factors has to be 0, or maybe both. Okay, that's kind of the crux of one of these problems down here. So let's go back and take a look at number 1. Let's do number 2. You guys have the odds here, and these are relatively similar. I tried to match. 1 and 2 are kind of similar to each other, and 3 and 4 are kind of similar, and 5 and 6 and so on. So as I do some example problems here, you can usually apply that over here to the other side. Maybe not in every single case, but let's go ahead and do a couple. Okay, so step 1 is you have to make sure that you have a 0 on one side of the equation. And the reason why that's important is because we're going to apply this zero product property, and if you don't have things that equal 0 or things that are multiplying to 0, then it's not going to work. Okay, so that's step 1. In number 2, we already have that ready to go. Okay, step 2 is factor the polynomial. So here we have a quadratic trinomial. So I'm going to use this little cross method, and I'm looking for factors of 18 that combine or add to be 11. That's going to be 9 and 2. And since my coefficient here is 1, basically the coefficient of the linear term, or the a part, is 1, I can take those numbers here, and I can put them right into my linear factors. Okay, so this degree 2 polynomial, this quadratic, factors into 2 linear binomials. Okay? All right, so factoring we know how to do. That's not too new. And I went through that a little fast because I assume we've been factoring trinomials for a few days now. But step 3 and 4 have to do with the zero product property, especially step 3. So think of this like my A, and this is like my B, going back to the zero product property. You actually don't need to label it like this every time. I'm just trying to connect it back to this idea. So I have two things that I'm multiplying, right, an A and a B, and the product is 0. So that means either the first factor is equal to 0 or the second factor is equal to 0. It's a little harder to kind of conceptualize this when the factors are binomial, but it's still true. So basically either my first factor, x plus 9, is equal to 0. Oh, sorry, these are n's. I changed from x's to n's on accident. In this case, we have n. So either n plus 9, is equal to 0, or maybe n plus 2 is equal to 0. So just using the zero product property, and my quadratic that became 2 linear factors has now become 2 linear equations, and these are pretty easy to solve. For the first one, I'm going to subtract 9 from both sides. The second one, I'm going to subtract 2 from both sides. And these are my two answers. Now the way you're going to see the answers written on the answer key is in what's called set notation. So we have these curly brackets here, and we just list all the solutions within the brackets. So the solution set is -9 and 2, and that's it. So the zero product property really is what allows us to go from factors, linear factors, to linear equations and solve. So that's kind of the crux of the problem. And when you look at these steps here, step 2, factor the polynomial, that might mean several different things because we have several different methods of factoring. So we're going to take a look at a couple more situations here and see if we can talk about some different factoring scenarios. Okay. Let's look at number 2. Okay. Number 2 is a little bit different because we don't have a 0 on the right. We have a 6. Like over here we have a 0. And remember, because we're applying the zero product property, we need the right-hand side to be 0. So going back up here, step 1 is to move the terms if necessary in order to get a 0 on the right. So in this case, I'm going to subtract 6 from both sides. And now I have a 0 over there. Okay. Again, this is a quadratic polynomial with like a coefficient of 1 on this quadratic term. So I'm just going to need to find the factors of -8 that combine to be +2. I'm going to have a +1 and a -1 because they have to multiply to a negative number. And I think it's going to be a +4 and a -2. Okay, so these guys again can go right into my linear factors. Okay, we're going to apply the zero product property and set each linear factor equal to 0. So I'm multiplying two things and I'm getting equal to 0. Either this thing is equal to 0 or this thing is equal to 0. Okay, I'm going to solve both for x. So x is equal to -4 or 2, and in set notation, that's going to look kind of like that. All right, let's move on to 5, 6, 7, and 8. Okay, now we're not going to do both of these, but I will pick one to do with you to help you out here. So let's take a look at, well, one of the things I wanted to point out here, I think I did 8 in class, so maybe I should do another one. But the idea here is that we don't have a 1 as a coefficient anymore. So that's actually going to be a different factoring method. And if we could, we'd want to factor out the common factor here. But it doesn't look like that's going to happen. So we're going to go ahead and multiply 25 by 32 and see if we can factor that guy. I'm just getting out my calculator here. Sorry, stand by. All right, sorry about that. It wasn't right on my desk. So I'm going to do 6 with you because I think these numbers are going to come out pretty big, and that might be a little confusing. So let's take a look together. All right, -800. That's pretty big. We're looking for factors. Oh, sorry. Let me kind of go back. Because I can't factor out this 25, I'm going to have to do the AC grouping method. So I multiplied A by C. That's going to give me that -800. And then I'm looking for factors of 800 that combine to give me a -20, keeping in mind that I have a positive and a -1, and the -1 is going to be bigger. So I'm thinking it's going to be maybe 40 and 20. Yeah, I think that's right. So it's going to be a -40 and a +20. Okay, so that I saw those numbers there, 25 and -32, and I started to panic thinking that was going to be really hard, but we got it pretty quick. All right, so from there, what we're going to do is we're going to split the middle term. Let's see, let's go plus 20x minus 40x minus 32. Don't forget the equals 0 because this is an equation now. And now one of the options here is factoring by grouping. I showed you guys a shortcut yesterday. I think based on what I saw, most people are more comfortable with the grouping method. So let's go ahead and do that. So we got to take out a 5x, and we got 5x plus 4 in here. Here it looks like the common factor is 8. I'm going to take out a negative with that as well, since there's a negative there. And that's going to give me a 5x plus 4 as well. Okay. Factor out that common binomial. And what's left is the 5x minus 8. Okay, now I went through that kind of fast, but that is not new. We've actually did that for the last couple days. We've talked about factoring those. So hopefully that AC grouping technique is getting a little bit more familiar. If it's not, I would go back and check out some of the videos from previous classes or go review your notes, because that's just like one of the steps in this problem. So we're not done yet. We've just factored. Okay, but remember, since we have an equation, we're going to take each linear factor now, 5x plus 4, and we're going to set them equal to 0. 5x minus 8 equals 0 as well. Now we can see that this is probably not going to work out to integers, and that's okay. We're actually going to get fractions here, but that's not a problem. So for this thing, I have 5x equals negative 4. Over here, I'm going to add 8 on both sides, kind of just doing these both at the same time. And then I'm going to divide both sides by 5. So that's also not new. We know how to solve linear equations. That's just going back to 8th grade stuff. So subtract or add the number first, then divide out the other number next to x. So our two solutions here are going to be negative 4 over 5 and 8 over 5. So step 1, make sure the equation is equal to 0. That was already done. Step 2, factor the polynomial. Okay, that was kind of the long step. Step 3, take each linear factor and set it equal to 0. Step 4, solve each of those equations for x. And there you go. Okay, 8 I did in class, but if you missed class today, I'll help you get started. We kind of saw this up in number 4 as well, same kind of scenario, where we didn't have a 0. So your first mission here is to add 48 to both sides. So 5x squared minus 46x plus 48 equals 0. All right, so now we can use that zero product property. The next step would be to factor it. Notice that I don't have a common factor that I can take out, so I'm going to use the grouping method. Got 5 times 48, and then let's see what that's going to be. So that's 240 up here. And then on the bottom, we're going to have a negative 46. So we need factors of negative 46 that combine to give us 240. I think, yep, it's 40 and 6. So those are the two magic numbers. Okay. Now that I've gotten you this far, what I would do is break this up into 4 terms, just like we did here. And then factor by grouping, or by the shortcut method I showed you yesterday. And then solve, set each of those equations equal to 0 and solve. So I just wanted to kind of set this up for you and show you what you do when you don't have a 0 over there. You got to move stuff around until you have a 0. Okay, so you can take it from there. All right, let's look at a few binomials. Okay, in number 10, we have a binomial here, and that means that we don't have 3 terms, we only have 2. If I go back and look at my steps, the first one is to make sure that we have a 0, which we do. Okay, then we want to factor the polynomial, and the reminder is don't forget to check for a GCF. So this one is a completely different method of factoring because it's not a trinomial. What we want to recognize, though, is that it looks like they both have a common factor of a, and for sure 12 goes into this one, so maybe 12 goes into this one. Let's find out for sure. Okay, yeah, it looks like 12 goes into 156 as well. So what I can do is I can undistribute a 12a, which will leave me with an a and a negative 13. So just to double check, 12a times a is 12a squared, check. 12 times negative 13 was that negative 156, and then since I had an a in there, I also get an a right there. So this one looks a little different, and what you'll maybe notice now is that I still have 2 linear factors, but one of them is a monomial. It only has one piece, it's one product. This is a binomial, it has 2 pieces separated by a subtraction sign. But we're still going to do the same thing. We're going to take each linear factor and we're going to set it equal to 0. That's the zero product property. So think of this as one factor, we'll call it a, and think of this as another factor. We'll call it b. So if a times b equals 0, either a is equal to 0 or b is equal to 0. Okay. Now that might have been a little confusing because there was already an a in the problem, but the reason why I'm just going back to this idea here that we talked about, zero product property. So I'm just considering all of this as one factor and this as one factor. Either this factor is equal to 0 or this factor is equal to 0. Okay, now from here we solve. So the bottom one is similar to what we've been doing. A equals 13. The top one, all we need to do is divide by 12 and we get a equals 0. So when you take 0 and divide it by 12, you get 0 as a solution. And you'll probably notice that that happens a lot when you have a linear monomial. If ever you factor out like a variable like a, and it's a linear monomial, one of your solutions is going to be 0. All right. Okay, so number 12, step 1, right? Make sure we have a 0. And it doesn't have to be on the right side, but in this case, it looks like most of these are. Okay, step 2, factor the polynomial. Don't forget the GCF. So what a lot of people do is they see this guy, and they're like, oh, I got a coefficient right there. So I guess I'm going to have to do AC grouping. And they start by multiplying 7 times 49. And they're like, okay, I got factors of 343 that subtract or that combine to 56. But before you go and do that, before you start getting too, factor happy, check for that GCF. Okay, these all have a 7 in them, and this problem is going to be so much easier if we take out that 7 to begin with. So let's do that. Let's factor out a 7. That leaves me with v squared minus 8v plus 7 equals 0. So now notice how much easier that is going to be to factor. Right? It's just now if we ignore this for a second, which is just going to be one of our factors, we're now focusing on this trinomial. We can consider the coefficient here inside the parentheses as a 1. And so all we got to do is find factors of 7 that combine to give me a negative 8, which is going to be those two guys. So what I have is the 7, the greatest common factor that I factored out. And then I have a v minus 1 and a v minus 7. These numbers, again, since after we factored the 7, the coefficient on this v, now that we factored the 7, is really just a 1. And so these two guys can go straight into our linear factors. Okay, now the next step is to set each linear factor equal to 0. So linear means degree 1, or the variable has a power of 1. So up here, this is a linear factor. It's a monomial, but it's linear because that's a to the 1 power, right? And this is a linear because that's a to the 1 power as well. This is a linear because there's a v to the 1. This is linear because that's v to the 1. But this is actually not a linear factor right here. This is a constant factor because there's no variable. So we don't actually have to worry about that factor. We don't have to set it equal to 0 because it's not linear. But even if we did, that would look something like this. Either 7 is equal to 0, or v minus 1 is equal to 0, or v minus 7 is equal to 0. So notice there's no variable in here. This is just an equation that's never true. 7 is not equal to 0. There's no way we can get like v by itself because there's no v. So even if you were to take that linear factor, or excuse me, that constant factor, and set it equal to 0, that just doesn't make sense. And you can just kind of continue from there. So we're going to add 1 to both sides, add 7 to both sides over here. So v is equal to 1, v is equal to 7. And my solution set is 1, 7. Okay. Now number 14 is actually similar to number 10. Right? Notice that it's already set equal to 0. There's a constant, or excuse me, there's a greatest common factor. Happens to be x. Okay. You can't take out a number, but that's okay. So what we're going to do now that we've factored it is we're going to set each linear term equal to 0. So either x is equal to 0, okay, that's already solved, or 3x plus 11 is equal to 0. All right, subtract 11 from both sides. 3x equals negative 11. Divide both sides by 3. So those are our two answers. Sorry, I forgot one of them. Let's put them in brackets and then put a box around it. So curly brackets, we got 0 as one of our solutions, and negative 11 over 3. Okay, so this x that we took out becomes one of our linear factors, and the other linear factor is this. So either this guy, like these two factors multiply to 0, so either this one's equal to 0 or this one's equal to 0, and that's what I have here. Okay, 16. Now on this one, notice that there's a degree 3. So your initial reaction may be, oh shoot, well that's not quadratic. I don't know what to do here. Well, it's true, it's not quadratic. This is a cubic trinomial. But also notice that each of them have an m in it. In addition to that, I think each of them have an 8 in it. I know 8 goes into that, and I know 8 goes into that. So fingers crossed, does 8 go into 616? Hopefully it does. Hot dog. Okay, so we can actually factor out a greatest common factor of 8m, and that is going to make our life so much easier. I mean, think about if you multiplied 8 by 616, and then you wanted to find factors of that combine to give you that. Yeah, you don't want to do that. So again, on my little guide, my summary here, we wrote something similar in our notes. Yeah, don't forget to check for that GCF. Okay, when we take out the 8m, we have an m squared minus 4m, and that's a little bit too big for me, so I'm going to divide here using a calculator. 16 divided by 8. Oh yeah, that's right, forgot. So that's a plus 77. All right, now that's actually not too bad. Like the 8m, we can kind of ignore it for a second, and we're just factoring this now, this trinomial. So I just need factors of 77 that subtract to 4, combine to 4. Oh, sorry, this was a negative 77. I was just thinking in my head how that's going to work out. Okay, that's much better. So one of them has to be positive and one of them has to be negative. And when I think of the factors of 77, there's only two, other than 77 and 1. The only other options I have are 7 and 11. So it looks like I'm going to have a negative 11 and a positive 7. All right, now we could do this technique that I showed you where we split the middle term, right? And we factor the quadrinomial by grouping, but we don't actually need to do that in this case because remember this thing that we're factoring here, a is equal to 1. So these two guys can go right into my linear binomials without doing any extra work. Don't forget that we had a, whoops, we had an 8m, sorry, writing in pen and it's hard to erase. Okay, so 8m times all that stuff equals 0. Okay, now this one's a little bit tricky. Remember we started out with a degree 3, so technically it was a cubic. However, as a part of that problem, we ended up with a quadratic. Right? We have a quadratic and a linear. So a degree 1 and a degree 2 multiplied will give you a degree 3. So we actually have 3 linear factors, and we need to set each one equal to 0. So running out of room here, but that's okay. We got 8m equal to 0. We got m plus 7 equal to 0. And then we have m minus 11 equal to 0. So this is a linear factor because it has a variable in it, a power of 1. This is the variable has a power of 1. So m to the 1, m to the 1, m to the 1. All right, so divide both sides by 8. M is 0. Subtract 7 from both sides. M is equal to negative 7. Add 11 to both sides. M is equal to 11. So altogether, we got a 0, we got a negative 7, and we got 11. Those are our 3 solutions. So this degree 3 actually has 3 solutions because we ended up with 3 linear factors. All right, now that we pretty much, I mean, we didn't go through every single one, or did we? Every single even, I mean. So we went through a lot of them. I didn't finish number 8, but that's basically the evens for you. So when you have those, or if you needed help, like you should now be able to look at the odds because they're similar. They're like structured similarly. Like these ones both have equal to 0, no coefficient on the quadratic term. These ones both have a number over here, so you have to move it over. All right, these ones both have a coefficient here that can't be factored out. So they're kind of similar. Not every single one is as a but they're for the most part pretty similar. That should help you guys get going on that one. Okay, this will definitely help you practice your factoring techniques. So, yep, a little more practice for you, and a little more application as well. Thanks for watching.